Hello everyone. Today is day 10 of our challenge solving 30 deep learning projects in 30 days. So the problem is about use pre-built data augmentation methods in Keras on Fashion MNIST dataset. So let's start with the flow that we have been following for all our previous problems. We'll go and use ChatGPT to give us everything. The intent of this challenge is to solve one problem every day and learn by solving the new concepts and increase the complexity gradually. So I'll go to the chat GPT. I'm going to use the same window as I've used for the previous nine uh, problems. So yes, I'll say hey, it is day nine, sorry, day 10, and here is the problem. Okay, so let's wait for it to generate everything and then we'll follow this thing. Okay, let's start. So it says that awesome 10 days is all about data augmentation, which is a great way to improve the performance and generalizability of your model. Let's dive into the Fashion MNIST dataset and apply data augmentation using Keras. Okay, so it is a way to improve the performance and generalizability of the data of the model. We will be using Fashion MNIST dataset. Uh, so, what is data augmentation? It is a technique used to artificially expand the size of training dataset by applying random transformations like rotation, shifting, flipping, and zooming. Okay, so we are going to data augmentation is that we are augmenting the data, which means we are applying techniques to expand the size of the training data set by applying these techniques. Uh, Rotation, shifting, flipping, and zooming. And these techniques will be applied randomly. To what? To increase the expand the size of the training data set. Okay. It how does it help? It helps improve the robustness of the model by making it see more variations of the data, thus reducing overfitting. Okay. So what it does, we are not passing more data, we are passing more combinations of the data so that our model becomes robust. Um, uh, and then and thus reducing overfitting, as in we'll train our model to on many variations so that on the validation data it is going to perform good. It should not perform good only on the training data on the by model being trained on multiple variations that we are going to get from data augmentation. The model will see the many variations and then going to on good to perform good even on the unseen data. So the Fashion MNIST data set contains grayscale images of closing items. Okay, so it contains the grayscale images on the closing item where the classes are 10, like, oh, not clothing item, where the titles, so the data set is going to have 10 classes. Okay, so the goal is to load the Fashion MNIST dataset, build the CNN model. Then we are going to use the Keras pre-built data augmentation methods to generate more diverse training images. Okay, and then train the model and with the augmented data and see the performance. Okay, so let's start with. So it is not a complex topic that I want to ask again with easy examples from ChatGPT. I do understand it. So let's start. Let me create a new file for today's problem. It is going to be day10.py. Add it to the Git repository. Mention what the problem is about. I have a typo. Problem. No, I did not have a typo actually. So let me copy it and mention it. Okay, now we'll do what? Come back to our GitHub and import the libraries. The libraries are going to be um, TensorFlow.keras.models. Import, not import this from import sequential. And then how many layers we want to import? We want to import convolutional, max pooling, flatten and dense, because this is a CNN level. We are dealing with images, so we want to add this convolution layer. We want to apply pooling because we want to take out the maximum features, valuable features. Flatten because these images are going to be in the shape of 28 by 28 pixel, you can see here. And dense because we want, yeah, dense. And then we want to add dropout because we want to avoid overfitting. So let's add all of these from TensorFlow Keras.layers, import convolutional 2D, max pooling 2D, flatten, dense, and dropout. Okay. Then we are going to import the dataset from the Keras, which is Fashion MNIST. So from TensorFlow.keras.dataset import Fashion MNIST. Then we are going to import this image data generator, which we will be used for to apply data augmentation. From TensorFlow Keras pre-processing image import image data generator, and then we are going to import matplot.py plot as plt. We are importing this package because we want to visualize the data set. We want to visualize the data set, yes. No, not the data set. We want to visualize the performance, the accuracy and the loss. So now we are going to do what? Load the data. uh, so let's load the data. X train X validation data, and then Y train, and let's Y validation data, and we are going to use Fashion MNIST load. Once done, we once done. Now we want to visualize it, as in it is not listed in this code. I mean, but I want to see how the data looks like. I will be able to do it nicely using the pandas library. So I'm going to import that first. Import pandas as PD. Why? Because I'm going to convert these vectors in the form of data frame. And with data frame, it becomes easier to visualize the data, to see it in the row column format. So we will do what? Import the data frame. Let's do what? Let's first see the shape of these variables, not shape. And print x validation dot shape, print x y train dot shape, print y validation dot shape. Let's do that. And what run this day 10 file. So it is first downloading the dataset, and we see it has 60,000 images of 28 by 28 pixel. For training, okay, then it is going to be y target, okay, x validation. Was it? Yes. uh, X validation, it should be the correct for order. Now we see that the images are for 60,000 images kept for training of 28 by 28 size, and then we have 10,000 images uh, kept for validation of 28 by 28 size. Then we have again 60,000 one dimensional vector for our target values for training, and then we have 10,000 for our validation. So let's do what? Let's visualize it. How do we visualize it? We can simply visualize it by reshaping it first. So what we are going to do, x train will become uh, x train dot reshape. Here we mention 28. What do you want to reshape? We want to reshape this. We want to keep this as this, and we want to reshape this into what? So we'll do what? The shape of this is going to be 60,000, and this value, and then it is going to be 28 by 28. Okay, x string, and then y, not x string, x validation is going to look like x validation dot reshape, x validation dot shape dot zero, shape 0, which is 10,000, and then we have 28 by 28 because we have, yeah, this pixel size. Now let's visualize x train dot head. Not, we have shaped it only. If I want to show you the shape of x train dot shape and print x validation dot shape, let's rerun the code. We have like 60,000 rows images, and the columns are 74, 74. Correct. Now we want to do what? We want to visualize the data set. So how we will do that? We build the data frame. So we'll do that. X train data frame will be pandas dot data frame. Just pass this, and now print this x train dot head. Okay, run this. Okay, I guess we have to pass this flat. We have to flatten it first because, oh, not, maybe we do not have to flatten it. We were using the wrong variable name. Okay, so see the data here looks like it has 74 columns, and the values are like 22, 118, 188, 166. So the values will be in the range of values will be in the range of 0 to 255. So yeah, values are in the range of 0 to 255. Now we'll do what? If we want to visualize uh, same way the data inside the x value is going to look like. Now if I want to visualize this, what is there in the target variable, so I'm going to again convert it into a series using pandas, y series and y not data frame, because it is a one dimensional thing. So I will say y train and print y train data frame dot head, uh, and let's run it. See the data target is looks like in the numeric form, which is 90003, where 0 to 9, it is from 0 to 9, where each value represents a class. So I'll go and comment this. We now know how the data looks like. Now if you remember, we saw the data and the features. We saw the images pixel are represented in 0 to 255. So we have to normalize it, because if we normalize it between 0 to 1, our model, we will be able to train our model better and faster. So normalize the data, the pixel values between 0 to 1. So how do we do that? We do that x train is equal to x train divided by 255.0. X validation will be x validation divided by 255.0. Once done, we will do what? Apply augmentation using image. So now we have to apply augmentation on the data set. Okay, using what? Image data generator. So we will use Keras image data generator to class to apply data augmentation. And how do we do that? First, we create an object of data generation. We pass couple of we set. I mean, we pass couple of things here to configure it. We mentioned rotate the image by, okay, we for rotation we apply that rotate the image by 15 degree. Shift the width by up to 10% of the width image. Shift the height by up to 10% of the image height. Zoom in up by 10%, and horizontal flip, yes, randomly flip the images on this. So we are passing these things, that how, what to what degree rotate, height, width, shift allowed for, like up to what, zoom range and everything. And then once done, we are going to apply it to our training data so that it expands based on those techniques. And then once done, we are going to visualize it. So yes, let's first apply it, and then we will come back here and understand this piece of code. So we will do apply data augmentation using image generator. So we'll do what? Data image generator will become rotation. Range is how many? 15 degree. And then we have width. Shift range is 10%. Height shift range is 10. Zoom range is 10. Okay, not 10, it is in the not percentage. 0.1, 0.1, 0.1. This is also 10%. Then we want to randomly horizontal flip. Yes, we want to randomly flip horizontally as well. Now apply this data gen on our X training data. Once done, let's visualize the some augmented images. Visualize some augmented images. Now we are doing what? We have expanded, we have applied these techniques on our training data, which is going to alter the images. Our training data, our data set involves images and the classes, right? So let's visualize some images from our training data after applying these augmentation techniques. How do we do that? We take the X batch, Y batch from X training, Y training, and the batch size is 9. Create a grid of 3 by 3, okay, and which will give us the figure number and the axis. Here we show 3 by 3 grid using this thing, and show using in the form of image using this command. We want to turn off the axis, and yeah, let's show it. We have used this thing on, I guess, our day 8, so we do know what it is used for. And why are we doing it? Because we want to break after the first iteration, like batch size. So we will see how many images. We will see like 9 images, I guess. Let's see. So we'll do what? For X batch, Y batch in data gen dot flow. Here we mention X train, Y train batch size is 9 images at a time, and we are going to create a grid of 3 by 3 size, and then we'll do what, figure and axis will be plot subplots. Here it will be of size 3. The figure size is subplot as in how many rows and how many columns you want, and we are going to have fixed size will be, the figure size will be of 8 by 8, and then we are going to have one more row for what, for the range in 9, because the 3 by 3 matrix is of range 9 by 9. One thing, because just 1 2 3 4 5 6 7 8 9, how many numbers it has if we have a 3 by 3 matrix? 9, right? That's why that range. Once done, mention it for each cell. We are going to plot it. We'll say axis. So this will give us the row. So let's say if we have, the axes are going to be like, if we have an image 1, this is, I'll say 1. Difference between this and this in Python is division operators. Okay, 1 0 0. See, everything is equal. Is there any difference? Okay, so this is for the float division operator in Python. Difference is visible when dividing floating point values. Okay, for floating point, because we have normalized our values, pixel values, right? So they are going to be in the range of 0 to 1. So they will be in the range of, they will be in a floating point. So it is going to be 1 division by 3, which will be like, let's say we have a number 4. 4 divided by 3 is 1, and 4% 3 is 1. So the axis value is 1 by 1. Let's say we have a cell called 5. The I is 6 5. So for 5 it is going to be 1. 5 by 3 is 1. 5 more 5 this thing 5 mod 3 is 2. So the axis value is 1, 1 is to 2. So the cell value is 1 and 2. So this is how it is going to be calculated. And the axis value, we have the axis value, and we are going to show using im show, and we mention x batch I, reshape it in the form of reshape 8 8, not rate it, 28 into 28. Now we want to reshape it back into 28 into 28 pixel, and cmap which gray color. Now we are going to show, we are going to turn off the axis. I actually don't want to turn off the axis, because earlier or last time we did turn off the axis, but today I want to see if I do not turn off the pixel, what it is going to do. So the subtitle of, not subplot, subtitle is going to be augmented images, and then we will show it, and then we will break it after the first iteration. Let's go and run this. We have lots of print. Remove it, and let's clear it, and let's run our file, and we have an error. Let's clear it again and run it. We have an error at line number 37. Input to fit should have rank 4. Got array of shape this. Okay. Oh, reshape the data and to add channel dimension. Okay, we want to add the channel dimension. Oh, we do not want to flatten it. I was wrong here actually. Sorry. Here we do not want to flatten it. We want to add one more for our grayscale channel. So it is going to be 28 28 1, 28 28 1. Okay, now let's run it. Okay, the data looks like this. Looks like band. This looks like bag, t-shirt, shoe. Let me take screenshot, and this is how the augmented images look like. Really nice. And if I don't apply, okay, yeah, that's why I'm seeing it. Yeah, so good. Okay, now we do visualize it. It is done. Now we see how the images look. The data looks after applying augmentation. Define the scene and model, and let's train it. Let's define the model. Uh, Build the model. So model is going to be sequential model, and then where we add layers. So model dot add convolutional layer. Do we want to start with? We want to start with 32 neurons filters, and the size of the filter is going to be 3 by 3, and the activation function is going to be rectified linear unit, and the input shape is going to be 28 that we have reshaped it to 28 28 1 for the grayscale channel. Let's apply the second layer, which is max pooling 2D of 2 by 2 filter. Let's add the second convolutional layer, and it is of 64 size. I did not see, but it is correct. Yes, the size of the filters is going to be 3 by 3. Activation function is going to be rectified linear unit. Then model add the next pooling layer of 2 by 2 size. Then we are going to flatten the images, apply flattening to convert the pixels this into a single list. Then create a fully connected layers, which is a decision layer to decide what the image looks like. Add a dense layer, which is of 228 neuron, and rectified, and the activation function is rectified linear unit, and model dot add dropout, add the dropout to prevent overfitting of 0.5, which is to drop out randomly 50% of the neurons, and add the output layer. Output layer is going to be have 10 neurons because we have 10 classes and we want to predict which class the image is going to be. Uh, so, since we want to predict, we are going to have the activation function as softmax, which is going to output the neurons in the form of uh, probability, and the sum of all the 10 sum of the output value of all the 10 neurons is going to be 1, since the probability is going to be 1, right? So once done, we are going to compile the model. Once done, model.compile, we'll do what? Add couple of things. The optimizer is going to be the add-on. We know what it is. We have done it in the day 4. On day 4, understood what it means and how it optimize. Now the loss function is not going to be the categorical cross entropy. ChatGPT does throw an error. I mean, the it does not work that way because we have numeric form of output, the classes, so that is why sparse, and they are or category so it is going to be categorical cross entropy. Categorical cross entropy, and the metrics are going to be what do we want to what would be the metric of improving the performance accuracy. Once done, we are going to build the summary, and once done, we'll do what? Train the model with augmented. Now we will train the model with augmented data, not the normal data, with augmented data. How do we do that? We use model.fit function. Here we mention data generation.flow, xtrain, ytrain, the batch size. Okay, and the validation data epochs and everything is going to be same. Model.fit data generation.flow. Here we mention not, let's do it this way so that it becomes for us to see. Data gen.flow. Here we mention xtrain, y train, batch size 9. This is how it is going to. This will generate batch size of 9 on the fly, the augmented data, and the validation data is going to be x validation, y validation. How many epochs you want? 10. And the purpose, yes, we want to see it being trained. We did not mention the batch size here because this is how it is passing the data in the batch size of 9, so we do not need to pass it explicitly here. Once done, we will store the training information in a history variable, and then once visualize the performance. First we will do a plot the loss, and then we will plot the accuracy. And so before that, first we need to convert this history into a data frame because the plotting with data frame becomes easier. So we will create data frame of this history. Then let's create a figure of size 10:6. Yeah, fixed size of 10:6. Then plot this the loss. It is going to be in string format. This is the label is training loss, and we have the same typo that we have been doing for all our problems. Then plot the history, the validation loss for our validation data. and the label is not lambda. Label is going to be validation loss. Then we are going to mention the not x label. The x side is going to be the box. We are plotting on y side. We are plotting the loss, and we want to see which line represents what. So let's let them, and then we want to see the data. One more thing I missed. The title of the plot is going to be training and validation loss. Okay, and I'll just copy it and move one line, extra line, and use it for our accuracy. Now replace everything. Everywhere where you see loss, just replace it with accuracy, and this will not this. This will plot for accuracy. One accuracy. Understand? We are done with the coding part. Now let's do what? Let's let's do what? Let's comment that thing that we had, because you already saw how it looks like. I will not have to comment it, but just run it. This is how it is going to look like. And come back here. Now this is the summary of our model. How many layers it has, we can see. How many parameters it has, we can see everything. And now it is training, so it is going to train a lot because the data has increased. So even for first epoch it is taking 25 seconds. We have 10 epochs, which means 25 into 50, 50 into, yeah, so it is going to take uh, 2.5 seconds, 2.5 minutes. So you can fast forward it to 2.5 minutes. I'm going to wait, but we can see that the starting loss is 0.78 and the accuracy is 70%, which is really good. The validation loss is 51, and the accuracy is 79, which is also good. Let's see how it is going to end with, at what accuracy for training and validation is going to end with, and at what accuracy the loss and the validation loss is going to be. We see that the accuracy is slowly increasing. It is now 82%, which is really good. And for validation, the accuracy is 85%, which is also good. We are on the sixth epoch. Okay, we see. Let's look at the epoch, 10th epoch. The loss is dropped from 78 to 43, which is good. The training is 84% for so the accuracy is 84 for training data. The validation loss also was gradually decreasing, which is good, which is a good sign. It stopped at 36, and the validation accuracy is also something similar, 86. So this is performing really good on the validation data as well, which was the case. That is why we applied data augmentation, because we wanted to avoid overfitting. And we see here the loss is gradually decreasing. There is a sharp decrease here in the first epoch, and then it is gradually decreasing. In the validation it increased, so the stability is not that impacted here, so we see the increase decrease here as well. So this is a good sign, it is performing really good. Then we come back here. If we look at the accuracy, it is increasing gradually, which is a good sign. For the validation, we again see some spikes here, but yeah, it is a good sign. The spikes are not that much, so it is performing really good. If we would have increased the box from 10 to 20, or may have played a little with the batch size, we can see some improvement in the, not here actually, here played a little with the batch size while doing what, while training, we could see some improvements in the model's performance. But yeah, it is good to understand that what we can do with data augmentation. So yeah, we have learned how to apply data augmentation using image data generator by passing this config with these settings, and then we train the data, and then after that we pass the same data in the form of batch size while training the model. Let's do what? Let's commit this code and mention the message would be day 10 code, uh, and it is day 10, and push to our main branch origin main. Let's go see the repository. Here we see that the day 10 problem. So yes, we can see it. Now we will come back and solve day 11 problem. Thank you.